All right, so now derivatives of our inverse hyperbolic functions. So it works the same way. If you see this, whatever we have here, we're just going to replace it and then continue. So this would be our chain rule, and I like to write parentheses. So we're going to put hyperbolic cosine -1 parenthesis and change it into a general power. And then we'll put it in the same way before. So for the derivative, we just use the formula. That's all these are, is formulas, formulas. So we're taking the hyperbolic cosine, and so it's 1 over this. So 1 over square root parentheses squared minus 1. So whatever you have here, you're just going to place in here. So we had a square root of x, so we'll put square root of x there. So we're just taking this and placing it here, like that. Now we have to take our inside and take the derivative because it's still chain rule. So our inside is x to the half. So the derivative of the inside would equal 1/2 x to the -1/2, which equals 1 over 2 rad x. And then we tack that on to the end, just like that. So it's just basic chain rule, but you use a formula. So f prime of x is equal to 1 over square root of x minus 1 times 1 over 2 rad x. Now, since that is a radical, we can put it in and write it this way. So 1 over 2 square root of x squared minus x, just like that. So either one is fine, but there is our derivative. All right, now let's try one with product rule. So we have an x and we have an inverse. And the way you can tell this is product is there are two x's, like looking at it, not literally, we're not 2x, but you get the idea. All right, so let's do x as 1, and then now the inverse is just this. So this is exactly a translation. It's a pure formula, 1 minus x squared, just like that. And then now we can multiply it. So just like our normal cross multiply thing. So it's tangent h, hyperbolic tangent inverse of x, plus, and then that x will just go to the numerator, x over 1 minus x squared. And there is your derivative. Just like that. All right, let's try one more now. So let's try one with an e to the x in it. So we're going to take our hyperbolic secant inverse, and it would give us this. So we're going to replace that x that's in there with e to the negative x. So we end up with -1 over e to the negative x square root of 1 minus e to the negative x squared. And then again, we got to take that inside and take its derivative. So let's double check everything. We have our -1, and it's e to the negative x. We put the negative on there. That's good. 1 minus e to the negative x, perfect, with a square. All right. Now derivative of the inside. So the derivative with respect to x of I is negative e to the negative x. So that's what we're going to tack on here. All right. So that's our g prime of x. So normal chain rule. All right, so you can see that negative cancels with that negative. In fact, this looks horrible, so I'm going to move it over a bit. Make it a little clearer because I've got all this room. Let's get rid of u, put a parenthesis. All right, so there we go. So we rewrote it, replaced the derivative of that one there. So the negative cancels with the negative. We can make that a plus and a plus. This will cancel with this one. And so we end up with just 1 over square root of 1 minus e to the negative 2x. That is multiplication. That happens there. And there you go. There's your derivative. So there's derivatives of inverse functions, inverse hyperbolic functions.